Hello everybody, this is Stefan Petersen from Aarhus University speaking, and this is a short video on how to use ICEbear in Grasshopper. So ICEbear works across different drawing platforms. There's another video here on the side that shows how it works in SketchUp, and it in fact also works in Revit, and that will be shown in another video soon. But this video is about how to make ICEbear work in Grasshopper. So of course you need to have Rhino installed on your computer together with Grasshopper. And here I have made a very simple model of a room that has been parameterized in Grasshopper. And let me just show you. There are so many different ways that you could make a parametric model in Rhino Grasshopper. This is one way to do it. So here there's some free variables on the room length in that direction, the room depth, the room height itself there, and down here there are some window variables, the height of these two windows, the width of them, and the offset from the floor, and the offset from the wall. So you could have whatever parametric freedom you want in your model, and this is a very simple shoebox model also. You could have whatever geometry you like. I mean, all the freedom that you have parametrically in Rhino Grasshopper is something that ICEbear can use as input for simulation. So yeah, I don't know, we just want to examine the consequences of the different settings of the window variables, for example, in this model here. So let's see how we can connect ICEbear to this simple model. So there's of course a lot of stuff going on to separate the different areas, window area, floor area, ceiling areas, all these surfaces that are important to a thermal simulation. You can do that in many different ways, and it depends on the complexity of the model that you want to make. But what you have to end up with, no matter what you do, is some lists with constructions in them. So here we have a list of items containing floor areas, ceilings, inner walls, facade, so that is external building envelope elements excluding the window geometries, because the window areas are down here. So here you can see, for example, what we have here in this window area is a collection of breps. There are two windows here, which fits very well with what's in. You can see on the Rhino model that we have two windows, and then there's a facade area. So there's one value here as well. And what we also need is the floor area, and that's basically it. Depending on what the boundary conditions are for the remaining part. If your ceiling is not facing outdoor, you basically don't need it. If your walls, inner walls it's called here, is not facing outside, then you basically don't need them either. But if they are facing outside, we need to have them in our energy calculation as well. But how to connect this geometry to ICEbear? And what I want to demonstrate here is how we do that with the ICEbear GUI. So we drag and drop this ICEbear GUI into the canvas here, and now we have to add all our construction areas to the ICEbear model. So we have the floor, which in our case is not floor on ground, it's floor, so it's not facing ground, it's not facing outside, but we need the floor area to calculate ventilation rates and different other things, which is in per square meter floor. So we have some floor area, We don't have a ceiling facing outdoor, we don't have the inner walls, so we don't need to do anything about them. We need to have the external facade, which is external walls here. And we need the window areas, which is external windows. And that's basically it. Now we have all the geometry that we have in Rhino, Grasshopper inside ICEbear. So now we should open the graphical user interface, the GUI of ICEbear, and up here you can see something called open. So we just need to add a bottom. So we find the bottom. Oops, bottom. Just here we are. And we connect that to open up here. So now we can open ICEbear by pressing our bottom here, and that will open the graphical user interface of the program, which looks like this.
So the first thing we can do is to check whether the geometry from our Rhino Grasshopper model has been transferred into ICEbear, and we can check that by clicking here, check geometry input, and that gives us this window where we can see that there's some floor area and some external walls and the fenestration area, and seems like it has transferred the geometry as we wanted it to. So in order to make a thermal simulation, we do have to specify more than just the geometry, and the short version of that in ICEbear is to fill out these 4 inputs over here. So deciding how many people are there in this zone. Let's say that it's for 2 persons. And what is the location of this building? What are the weather conditions? And I'll just choose a Danish design reference here as the location. We have to decide what type of glazing system do we have in our window, and we could just have a double layer low E coated glazing to start with. And finally we have to choose a zone template that defines all the other settings that is needed for a thermal simulation. I'll just choose a template here. In another video I will go through what's in a zone template, but here it would be a landscape office with the variable air volume ventilation. So I just choose that one. And then we can press simulate, and then it will simulate the thermal performance of this geometry with the input that I just provided to the thermal simulation right here. And that's done now. And then we can see a number of results here to the right. There is something about energy. There's something about daylight. There's no daylight calculation connected to this simulation yet. That input can be made with any other plugin, for example Diva or Honeybee. We're also developing one for ICEbear, and it will soon be presented. The thermal indoor climate can be evaluated according to thermal comfort evaluation in a European standard, and the same goes for the air quality. And here we can see there's a substantial amount of overheating in this room, and there are several ways of presenting these results. You can go to this more simulation result here, and then we could look at the hours above curve and see that it's completely off the chart. Over here we can see it's many hours above what is usually the overheating criteria of a building, 26, 27, 78 degrees. Maximum temperature is extreme. So maybe we should do something about that. And one way to do that in the geometry, for example, would be to reduce the window size. So we could start doing that so you can see how it works, at least in terms of the geometry manipulation. So we go to the window geometry variables, and then we could take the window height and just for fun make it smaller. So you can see it over here that it's smaller. And then we can go back to the ICEbear user interface and check whether that happened. And yes, it did. Now it's only 2.88 square meters. Let me just show you again. Window height, I don't know, something like that. And then checking it here, you can see the area of the fenestration is changing as I'm changing it in the model. So it's very easy, and it's directly connected to the ICEbear interface once everything is set up. So yeah, let's make it smaller and see how the thermal simulation respond to that. So right now it's pretty overheated. Now we'll simulate. Let's see, class 4 for example is 37.6. And now it's 12.7, so definitely reduce some overheating. We can go and see this hours above thing. Yeah, it's much different now. Maybe it's still a problem, but it's definitely much less now. And we can continue manipulating our model to make it work as we wanted to and fulfill the performance criteria that we would like it to. We could change the glazing over here, for example, to I don't know, a 2-layer with a dark solar coating, and do the simulation with this geometry again. See what happens. As you can see, the time consuming wise, it's the sun load calculation that takes up simulation time. When it comes to the thermal simulation, it's very, very fast. But yeah, that completely eliminated some overheating in class 4 and class 3 over here. If we look at the hours above, now it's a completely different game in terms of overheating. Maybe we could even have more glazing now. It seems a little bit too small maybe, and then we could increase it to something like this, and then try to calculate it again and see if this type of glazing would enable us to have a larger area but still fulfilling thermal indoor climate requirements. So now a little overheating came in again. I don't know if it's acceptable or not. That's of course different from project to project, but here it seems like it's not an unreasonable overheating scenario that we are in right now with this room geometry and with the components chosen. But that's it for this small demonstration video. I hope that you are now able to connect a Rhino Grasshopper model to ICEbear and start to make thermal performance simulation in your building design projects in a fast and easy way. Thank you very much for listening.